In this video, I want to have a look at midpoints and intervals. So we're going to have a look at this triangle to start off with. So we've got this large triangle ADE, and in there we've drawn in this interval BC. So B is the midpoint of AD, so that's halfway along, and C is the midpoint of AE, and we've joined those together. And we want to find out the properties of this interval BC. So we're going to start off by proving that the two triangles that we've got here are similar. So we're going to have in the big triangle, so in triangle ADE, and that small triangle, which is ABC, then we've got to find three things to prove that they're similar. So the first one that I notice is that this angle here is part of both triangles. So angle A is common. Okay, the next one along is looking at the ratios of the sides. So if we have a look at side AB compared to its corresponding side, which is AD, we know that AD is going to be twice as long as AB because we know that those intervals are the same length. So if we have a look at the ratio of those then, AB over AD would equal a half because B is the midpoint. If we do the same thing for this side along the bottom here, side AE, we know that AC is going to be half the length of AE. So AC over AE is going to be equal to a half. So from that proof then we have two sides that are in the same proportion and we have their included angle being equal. So therefore those two triangles are similar by the SAS test. Okay, so now we know that our two triangles are similar, we need to look at what we can pull from that. So we're focusing specifically on this interval here, so the interval BC, and its corresponding side in the larger triangle, which is DE. So if we have a look and compare the lengths of those, we know that BC over DE, so that's the one in the small triangle over the one in the large triangle, is going to be equal to a half. Because that was the ratio that all our other corresponding sides were in, and because they're similar, this one has to be the same ratio as well. And then we can manipulate this, and we can figure out that BC is equal to a half DE. So that just makes it read a little bit easier, that BC is half the length of DE. So this interval is half as long as this one. All right, the other thing that we can have a look at is those lines look like they're parallel, but we can actually prove it. And the reason we can prove it is because if we look at this angle and this angle here, they have to be equal in size because they're corresponding angles in similar triangles. And that means that these two lines have to be parallel because these are corresponding angles, and corresponding angles are only equal if the lines are parallel. So we'll write all that out as well. Okay, so what we can pull from that is a theorem. And we've proved two things about that interval. We've proved that the interval is half the length of its corresponding side, and we've proved that the two things are parallel. So to write it a bit more formally, we have the theorem that says the interval joining the midpoints of two sides of a triangle is parallel to the third side and half its base. It also works the other way around. So the converse is that if we have a line that passes through the midpoint of one side of the triangle, and it's parallel to the base, then it has to also bisect that third side.